Hello, have you tried to make your Antinano device, but your power supply was failing? And the automatic switch that you were using, the flasher or the relay, was as well burning out? If so, stay tuned because in this video, we'll explain why this is happening and what you can do to avoid it in the future. Hi, this is Yanis from Solution for Mankind, and in this video we're going to address the problem of the power supply, the electrical specifications of your Antinano devices. We're going to see what is the situation, we're going to see the problem, we're going to provide explanation why this is happening, the implications when this is happening, and of course, how to address the need to have an operating Antinano device and what you can do. So let's start first of all with the problem, the situation. In the past, I have been contacted from countless of persons with the same problem. Their power supply was not lasting long enough and either was burned immediately after they connected or after a few months, in the best cases, maximum a year, if they are using it continuously. And many, they were using it as well without even the intermediate device, the device between the power supply and their circuit, the wire, which is basically an automatic switch and creates this on-off function and then creates the pulses of the magnetic field, the main function of that now device. This, of course, was creating huge problems. I had to reply hundreds of times in the emails repeating the same explanations and the solution providing the solution. So when you have, this situation where you build your device, you want to use it to protect yourself and start removing this nanotechnology from inside your body, and suddenly you cannot use it because you don't have power to use it, of course, this is quite frustrating. Besides the delays that it's causing, it's, of course, can increase your budget because you have to buy again and again a power supply, a power adapter. And the worst of all is that beside the delays that is adding, it may as well frustrate you or has frustrated many people to the degree that they quit using the device because they came in the dead end. They didn't know what else to do. They had maybe replaced 2, 3, 4 times their power supply, and still it was having the problem. Why this is happening? Let me give you an explanation, because there are some videos outside here on the in the internet where they are talking about the power supply, the power adapter of the Antinano devices, but they are making a fundamental error, and it is an error. So pay attention on that, so you're not going to repeat the same error. There are cases where they connect the power, the DC power, to their wire, the triangle, or to the bucket directly. It will work for a while, but it will stop soon after. Why it works, why it gives these pulses, you can verify it with a magnet, with a compass, whatever, you see that it's moving. Not very fast, maybe with a rhythm of 1 hertz per, maybe less than 1 hertz per second. So pop, 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 something like that. But this is not the correct way. Why it's happening? The good quality power supplies, they have inside some protection circuits. They have protection, temperature protection, overheat protection. So if it will exceed a certain temperature, it will shut it down to cool down for protection of the circuits and the components. And most of them, at least the good quality, they have as well, all the good quality, they have overcurrent protection. So the power supplies, they are designed to provide a certain voltage, output voltage, and current, amperes. If the circuit starts demanding higher current than what the specific device is designed to provide, then this auto protection, overcurrent protection circuit will kick in and will stop the supply of the output. So the current will go down. Because it's going now down, it's available again. The auto protection circuit is stepping aside because now it's not needed anymore since it cut the supply of the current. But then when it cut the supply of the current, the circuit outside your triangle or your bucket again demands more current than what your chosen power supply can provide. It starts providing, it's exceeding the limit, and then the protection circuit again is kicking in. And this is repeating continuously. So you see if you have made it and you have your magnet, and you can see that there is a magnetic field, it stops. There is a magnetic field, it stops. So it creates the pulse, low frequency pulse, but at the same time, this destroys your power supply because it works all the time on the limit. And when we are having something always on the limit, of course, it's going to age premature and going to be destroyed much earlier than what is designed by the manufacturer. One more point on this, maybe you are not aware about it. What is written on the power supplies, on the specification on the label, usually you have, the input voltage, for example, 220 volt AC or 120 or 110, or maybe if it's a universal power supply, it's going to say 100 to 240 volts, so you can connect it all over the world. This is the input voltage. It has as well the input current, which we don't care that much about that. And then there is the output section on the label, where it says what is the output current and voltage, DC voltage, direct current that provides. It can be 12 volts, it can be 16, it can be 19, 24 volts, it depends. And then there is a number of the amps. 4 amps, 6 amps, 10 amps, 20 amps, 40 amps, whatever it is, the number of amps. This number is the number that the specific power supply is designed to provide, is rated to provide. So, for example, it can be 12 volts, 16 amps, 12 volts, 12 amps, 24 volts, 10 amps, or 6 amps. These amps, the amperage, is the maximum that this specific device that you have it in front of you can provide. Now, if we connect our load, as it's called, your wire, your triangle, your bucket, it will run current inside, okay? If the current that your wire demands, and the demand is directly relation between the output voltage of your power supply and the resistance of the wire, if the current is more than what this specific device you have can provide, then the auto protection circuit will kick in and it will cut it down. It will stop. And then, as I explained earlier, the auto protection will step aside, the current will start running again, but then it will exceed because it's demanding more current than can provide. The protection circuit will kick in again. It will stop the current and it will create this on-off reaction, which will aid your power supply. In this case, if we have not connected an automatic switch between them, the power supply is designed, can provide a lot of amps, for example, 100 amps. It's a killer. It's 100 amps, it's going to be a monster power supply. But then can provide, let's say, 100 amps. Your circuit, your triangle, of course, is usually not going to require so much amperage. So in that case, it will start providing the direct current, but there will be no pulse because it's going to run continuously. It's going to overheat, etc., because it's running a lot of current at the same time. But you are not going to have any pulse because now the power supply can provide, let's say it may require 20 amps, and your power supply can provide 100 amps or 40 amps. Since it is not reaching the upper limit, the protection circuit will not kick in and will not stop the current. Therefore, you're going to have the continuous flow of current Therefore, you're going to have continuous magnetic field, but it is not going to be pulsating magnetic field. This is how the power supply works. In order to have now a pulsating field, which is the basic action of the mode of action of the Antinano device, then you will need to insert between the power supply and your triangle or your bucket an automatic switch. It can be, manual if you want, and a switch that you press with your hand, on off, on off, on off, on off, but it's not practical. Or then you need to put an automatic switch, a relay or a flasher. So we put one automatic switch, electromechanical. The flasher relates electromechanical, and it creates this on-off function, and therefore the on-off of the magnetic field, the pulsating magnetic field, or it can be electronic switch. It doesn't matter, it's going to be one switch that's turning on and off. But this device as well, the automatic switch, should be rated for the current that it will pass from for your triangle, for your bucket. Otherwise, it may melt, it's going to be burned, it's going to stuck, it's not going to operate. You're going to have similar problem as with your power supply. So to recap, the wire of your Antinano device, the triangle, for your triangle or for your bucket, it has a certain resistance. It can be 1 ohm, it can be 20 ohm, it can be 1.5 ohm, it can be 2 ohms, it can be 0.5 ohms, it can be 0.3 ohms. It depends the length and the size of your wire. In order to have pulsating magnetic fields that will create the Antinano function to disengage the program of the nano, we use a power supply, a power adapter with direct current. You should not use AC current. Okay, it has to be pulsating, a square wave, if we can put it like that. So on, off, not continuously on, off, minus, on, again, as is happening with the AC current. It has to be on-off function, pulsating magnetic field. And for that, we need to have an automatic switch between the power supply and your wire. If we're not going to have this automatic switch with a correct electrical specification, of course, if we're not going to have this automatic switch, the power supply that we will connect, most probably we're not going to be able to provide the required current, and therefore the auto protection circuit of the power supply will kick in. It will stop the device providing the current that is required from your triangle, from your device, from your cable. Then, as soon as it will cut, of course, then it's below the limits, so the power adapter, the power supply, will start providing again current. Then the protection, it will go above the limits. The protection circuit will kick in, it will put it down again, and this will create a pulsating effect with a low pulse rate, but it will create a pulsating event. But this is wrong usage of the power supply. It will destroy your power supply soon compared to the expected lifespan of the device. It's nothing to do if it's wrong, let's say, if it's because of the specific brand, or if it's made in one country or in another country, or the best country, the highest quality of materials. It doesn't matter. As long as we use it always on the limit, it will age premature. It will age much earlier than what was supposed to be used and was designed to be used. This is the reason why the people that they have used wrong power supplies and wrong automatic switches, they have been burned their devices, or they have become extremely warm, destroying as well the insulation, simply because they are not using the components with the correct specifications. They think that because, okay, it's operating and we see a pulse, it's fine. Only to see after a few weeks or a few months or a few days or even a few seconds later that, oops, it was not fine, it burned or it stopped operating anymore. This, of course, the consequences of that is that you're gonna spend a lot of money again to buy again and again and again wrong power supplies because you don't know something better. Well, you buy what maybe you have heard in one video or somebody else who was explaining how to build the device, because they are not electronic engineers or electrical engineers. They had no clue about it. They just copy what they have heard from other people. And that is the issue of the problem, the cause of the problem with your power supplies. You are copying some information which is wrong. To fix this, you need to know the resistance of your triangle, and then utilize the Ohm's law and find out what is the correct, the required current that will pass from your circuit, and then buy components, power supply and flasher according to that specification. This is how they will last long, your power supply and your diode. If they are rated above the required current, because, for example, you may find out that it requires 10 amps to pass through, but your power supply should be able to provide more than 10 amps. The electricians, the rule of thumb, as we call it, we take always 20% higher. 20% higher than if, let's say, the current, the circuit requires 10 amps, then we need to have a power supply that will provide at least 12 or more. Why? First of all, one basic reason is that we don't use the power supply always to the limit. As we explained earlier, we give a space of 20%, at least 20% space, so it's not going to work always 100%. And the other reason is, okay, the components, the electronic components, even it's most expensive and very accurate, they may have a small variation of the name value. Okay, so we may design the perfect circuit and we have the best components on it. It may be a little bit off, 2% plus and minus, or let's say it's gonna give more or less of what is the name value. If you see the technical specifications of each device, there is a range. Yes, the name value, let's say the design is for 10 amps, but practically it may operate at 9 amps. It may be able to provide 9 amps, or it may be able to provide 11 amps. That's why if your circuit requires 10 amps, we better buy a power device that gives more than what we need. Because if the specific one, for whatever reason, instead of giving 10, but giving 9.5, there is a danger that the protection circuit will kick in again, or it will work always on the limit and will age premature. So buy always power supplies with higher current than what you need. How to find this one? Okay, as we said, we need to know the resistance of your wire. How to know the resistance of the wire? You need to use a multimeter and measure the resistance, and then you calculate with the voltage that your power supply has what will be the current that will be requested from the specific wire that you have. It's not one rule that applies in everything. You have really to know the resistance of your wire. How to do that and how to do the calculations? Okay, you can look online. You can ask your kids from physics, or if you know the physics, or I have created as well a paid webinar, but only $87, where I explain, I have a little bit of physics, I explain how the current works, I give examples, what is the formula to use, how to use it, and not only how to use it, but how to interpret the results. Okay, it's going to give you any specific number, and number that's going to come out based on the results of your measurements. Then what? I provide information how to choose correct the specifications and what to look for the power supply, for the flasher, because this is as well important. It needs to be able to support all this energy and all this current, and needs to be as well at the same voltage range than the power supply. For example, if you have a 12-volt power supply, but you are using a 24 volts flasher or relay, it's not going to work, or it's going to work for a short time, or the other way. So I give explanation in the webinar, and as well how to, it's because not only the power supply and the flasher, then you have the connectors. You need to buy connectors with the right specification, otherwise they will melt, they will be burned, they will be on fire. The same with the wire. Insulation of the wire needs as well to be rated for this current, voltage, and even temperature. It may pass from the specific current. So I have all this information and examples and photos and diagrams, schematics, how to connect everything, and some examples of connectors, good quality connectors that you can use, depending again what will be the power of your specific device. And this will be determined by the resistance of your wire and the voltage of the power supply. Those two, they will give you the amperage. And then you choose accordingly the power supply. So you don't buy first the power supply. First, you measure your wire. Then you decide what power supply to use, what voltage, and you calculate what will be the average, the current that the specific circuit that you're going to build requires, and then you buy the power supply. So for more information, you can purchase my webinar, or you can look online to find out the information how to calculate, and then you can go ahead and apply it, or you can buy the webinar where I have everything detailed. You're going to get the PDF with the slides and practical examples and practical informations to have finally an Antinano device that works, and it works daily and for a long time. There is no perfect component that will last forever, but it's easy to let's say, if you know what you are looking for, then it's easy to replace it. An alternative, of course, I built as well my devices. If you want to purchase a ready plug and play, either with electromechanical switches with the flasher or the relays, or a quiet one electronic switch where you can change the frequency of the pulse rate, you can change the duration of the pulse, so you have better control on the Antinano function, and it is as well silent. It is silent. The electromechanical switch, you hear the click, 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 so you have this noise. The electronic switch, they are quiet, they are silent. And as well, an indicator light when the magnetic field is on and when it's off. Okay, I trust this video was useful. We talk about the situation, we talk what is the problem, what is the cause of the problem, the implication of the problem, and as well what you need to do and the solution. See you in the next video. Take good care. Bye.